It's a video guide for the extra credit in mapping vulnerability. And in this guide, we're going to be using tornado data from 1950 to 2016. And we're going to be mapping to the county level for the United States. And what we want to derive is a tornado risk per county based on historical tornado segments. So to get started, let's review where we're getting the data. So in this case, we're getting it from NOAA, and we can see that we have tornadoes 1950 to 2016. It's just a simple download of those polyline features. The second component is the actual county geometry, and in this case, it has mobile home percentage. And there's a fair amount of research that's come out recently that suggests that mobile home stock per county is a risk. So as the count or the percentage goes up per county of the housing stock that is mobile homes, that's an increased risk. So we're going to use that as a variable to set our social vulnerability. So once we download this data, I'm going to go ahead and cancel out of this website. We're going to organize it into a folder. We can see here it is. So we have two folders, one for tornado, which is torn, and the second one is mobile home percentage per county. Let's go through the actual steps that we're going to do here. The first thing we're going to do is actually get the data, which we've talked about. There's also SVI, social vulnerability, that we could utilize at the polygon county level. I'm not going to use that for this tutorial, but it's 2014 data, and certainly you could replace the mobile home data with the social vulnerability that you find in the index. We're going to essentially do a bivariate mapping here. So we have two variables. One is going to be mobile home percentage, and the second one's going to be the actual amount of tornadoes that have hit a county or within a county. And we're going to break that into four components. The first one's going to be low incidence, low exposure, low incident, high exposure, high incidence, low exposure, and high incidence rate, high exposure. And we can break that out into mobile home per county versus low and high tornado risk. So we're going to have essentially four different classes or four different ranks that we're going to finally map, and that's going to be able to ascertain where there's most risk. What we're really interested in is this last category here, which is where the housing stock vulnerability is very high and the actual tornado risk based on historical tornadoes is also very high. If we take a look at our resulting data, we'll see that our median for mobile home per county is 11.2. So we're just going to simply break on the median, so low versus high off the median. And we're also going to find that 4.22 strikes per county is the median. So there's some that are going to be much higher than that, and those are going to go into our high risk pool, our high risk tornadoes. So we'll go through this when we get to these steps of the actual ranking, how we break out the percentages. We're going to run identity as a spatial operator tool, and we're going to split at the county boundary the tornadoes, and I'll explain that as we start working. We're going to summarize our data. We're going to take a look at the zero records back or no FIPS. So we're going to take a look at what happens in a no intersection, which is outside of a county. We're going to correct for that. We're going to then create a join with the sum output table to our county boundary. We also need to normalize our tornadoes, our tornado segments. So instead of it being per county square area, we're going to normalize to per 100 square miles within a county. And we're just going to run a simple calculation for that. We're going to calculate the geometry first for square miles, and then we're going to divide by 100, and then we'll divide that. We'll divide our counts, our actual tornado counts by that figure. We will assign our risk factors. So that's going to be our 8th step. And our 9th step is going to be actually thematically mapping our risk. Okay, so there's 9 steps to do this. And we'll go ahead and get started. So I've connected to the data. You can see I have a folder called MVEC set up. And I have 2 features. One's going to be the county. And this is in a planar system. And then I also have tornadoes. I'm going to bring tornadoes in. I'll put the tornadoes on top. Those are the purpley blue line. Let's make this line much larger. You can see that there's some strikes in Alaska, and there's obviously some that are off the coast of the counties. And these particular strikes are going to be the ones that do not actually end up as being counted. And so we need to correct for that as we're going along. We just want to make sure that we're not counting up these ones that are striking off an actual county boundary. Okay, so first thing we want to do on our step list here is we want to actually find out how many strikes have happened per county. And in this case, we're going to use identity to do that. So we're going to go up to Arc Toolbox, and we're going to do analysis step, which is going to be overlay. And we're going to use the identity tool. And what identity does is it looks for the intersection of what's coming in, and then it's going to identify that intersection so that we know where the strike is actually happening within a county. Okay, and it's going to give us back both the geometry result but also the attribute result. So right now we have, if we open this up, we have tornadoes. It gives us a date. It gives us some information about the actual tornado itself, but it doesn't actually have any information about the county where it actually is taking place, and that's what we want. So then these are polylines. Okay, so we're going to split the polylines at the boundary. So if we zoom in, where it crosses a county, we're going to create a new geometry and then also bring in the attribute of the county name into the segment. And we'll use Identity tool to do that. So here we go. So the input feature here is going to be the actual tornado. The identifying feature is going to be the polygon. In this case, it's going to be mobile home percentage. And I'm going to name it something and send it to default geodatabase. So I'm going to call this my, oh, I got that wrong. Let's start over here. Okay, and I'll say, instead of identity, I'm just going to say tornado county. And I'll run this and say OK. Now this is going to produce another feature. And then we're going to summarize this. So you can see it takes a few moments to actually write all this out. So I'm just going to pause the video as it's doing that. Actually, it completed it, so that's fine. So let's take a look at our result. Oh. Okay, so it gives us another polyline. And if we open up the attribute table, we can see that we have 70,000 strikes or segments. And now we actually have a FIPS that we can work off of, and that's really what we need. So if we come along here, we can see that we have a bunch of nothing, and then we have the actual county name and its FIPS, which is an identifier that we can utilize to do joins with. So let's just quickly take a look at where these are, all these zeros. So I'm just going to select these in the table, and there is looks like there's about 1,000 here. So I'm just going to, sorry about this, I'm going to zoom to layer, and we're just going to take a look at where this is happening. It's taking a second to draw. Let me get these windows collapsed here. So we can see this selection of 0, apologize there, is happening right along the edge. And if we zoom in, we can see what's happening is that it doesn't have anything to actually intersect with. And so it's just producing a result, an attribute result of basically 0. So we want to make sure that when we do our final summarizing that we take care of that problem, because we don't want to be counting up these strikes that are outside of a county. All right, so let's clear that out, and then we're going to go back to our attribute table here. And what we want to do is we want to summarize this table now. So we're going to summarize on the FIPS. So we can see if we come down here, it's going to have a unique number for each one of these counties, which is exactly what we want. So I'm just going to summarize this. And I'm going to create a summary table. And I'll just call this TORN sum table. And set default geodatabase. Okay. So here's our, I'm going to get rid of this geometry now. Actually, I'll just keep it in. So let's take a look here. So here now what we have is FIPS that we can do a join on. And we have counts per county. So now we can see that we have our zeros. Of course, we're a real high number. We're going to have to correct for that. But here's all our counts along the way for each one of these counties. So we'll just go ahead and join this now to our original county data. So we'll just go to join and relates on the mobile home and say join. And we're going to join using the FIPS. And it's going to see the table, FIPS. In this case, I'm going to keep all records and validate the join. And as I do that, you can see that I have pretty close to my 3,238 records, but it's not able to join those zeros. So I say close. There's also some nulls here too. I say okay. So let's go ahead and take a look at this now. So now we have this column that is going to be joined. And since I'm going to be working with it further, I'm just going to go ahead and export this to solidify the join. So let's go back into table of contents and just export this to default geodatabase. And this is, I'm going to call this my rank, or actually let's call it risk. Risk TORN underscore rank. So this is where everything's going to end up. Let's say yes. So I'll get rid of the original one. Okay, so here what we have now is we have FIPSs and we have a count, and these are linked into the correct counties. But we do have one issue that we need to correct for. So if we sort ascending, we can see that we have a lot of nulls, which is fine. And all the way down at the bottom, we have this 0 issue. So if we try to find the median off of our county here, it's going to result in a median that is skewing too far to our high values, and we don't want that. So we just want to make sure that when we finally figure out our median, that we correct for this. This really should be 0 or null. Actually, it should be null. So what we want to do, we'll take care of that in just a second. What we need to do now is we need to normalize, because we have different square area per county, and we need to do our normalization first. So let's do that process. So we're going to create a new field, and in this case it can be a double, and under the double, let's call this square area. So it's going to be SQ_AREA, and say OK. And under square area, I want to just calculate the geometry. So actually I need to select off first, clear the selection, and calculate the geometry. And in this case it's going to be square miles, and say OK. Okay, so there's our square area. Since we have very big counties and also really small counties, we want to try to normalize the square area so that we can compare our tornado strikes a little bit better and control for differences in area. So what we can do here is go to Field Calculator, say yes, and square area is just itself divided by 100, and say OK. So that's going to help us out here. So now if we sort, we're going to have zeros. We're going to have some very small areas, but we're also going to have per 100, we're going to have some numbers that are going to work a little bit better for us. And again, we've normalized here. Now what we're going to do is we're going to actually now figure out the actual number of tornado strikes per 100 square miles within each county. So to do that, we're going to make a new column, and we'll call that can be a double, and we'll call it norm for tornado, T-O-R-N, norm torn, kind of a funny name. And under Field Calculator now, we're going to just take our count, okay, our number of tornado strikes. Here it is, CNT_FIPS count divided by our square area. Remember, square area has been normalized, and we say OK. And that gives us our number. Let's take a look at it. So we're just going to sort ascend, and that looks about right. So at our very top, at 189, there's some very small geometries. This is down in the Keys. This county in Florida, Pinellas, gets quite a few tornadoes that come through. And let's see what it's at 35, which is about right. So it's getting 35 tornadoes per 100 square miles, essentially. But here's the problem, is this is our lurking off the coast 1,117 segments, and we need to get rid of that. So we're just going to send this particular instance to null, because we don't want that showing up in our statistics. So what we'll do is we'll say this selected feature, which is that one that has the county FIPS of 1117. All right, that's how many strikes it's had, but those are all outside of actual county. Okay, so its FIPS is 0. we want to send this particular instance to null. So we'll just say you're going to be null. And we should be able to just type in null here. Let's see how that goes. Yeah. Okay, so that's going to go along with some of these other nulls here. Now what we want to do is we want to find out where our median is within our tornadoes that have been normalized. We want to find out the median value for that, and we also want to find out the median value for mobile home. So let's go into geostatistic analysis, and we're going to explore the data. I'll just go to histogram, and I want to make sure that I'm in the right feature, which is risk rank total, and my attribute is going to be my norm tornadoes, and I can see that my median is 3.22. So that's where I'm going to break everything in my ranking. It's a pretty generalized rough rank. There's not a lot of subtlety to it, but it'll give us 4 classes that will produce some meaningful results. So for your extra credit, if you would like to finesse where your breaks are, or if you want to focus in on one particular state, or even use a different social vulnerability variable, those are all perfectly good options. Okay, let's go back to the analyst and run it also for mobile home. So under mobile home, our median is 11.2. So that's where we'll break on mobile home. So we'll call things that are not at risk for mobile homes to be less than the median, and ones that are of relatively high risk will be equal to or greater than 11.2. All right, so we're pretty close here to start ranking this up. I'm going to zoom to layer. And now what we want to do is we want to, just for a moment, just turn off the tornadoes. And we can start to work in the table. Okay. So we need to create a new table, or excuse me, a new field. And this is going to be, let's just call it our RR for risk rank. And we can have this be a short integer. We can just do 1, 2, 3, 4 since we just have 4 conditions, and say yes. And what we want to do here is start selecting within our attribute table for our 4 conditions. So the first one is going to be, we need to select by attributes. So let's go ahead and select our incidence first, and then we'll go to our exposure. So our first condition is low incident and low exposure. So we need to make sure we're in the right feature. So we're working in risk torn rank. And I'm going to first do my incidence, which is going to be the actual tornadoes, okay, that I've normalized. So this guy is going to be less than 3.22 and apply it. And we can see that we have 1,511 records that have been selected. You can see them on the map there. We can see these are kind of out of our tornado belt area. Lot of states in the West. With that condition, we want to go back to select by attributes. And instead of creating a new selection, we're going to select within the current selection. So we go to select from current selection. Now we're going to go to our exposure. So instead of tornado, now it's going to be the mobile home count. So mobile home is going to be less than 11.22, our median, and say apply. And that brings it down to 614. We say OK. And then we go into our risk column, go to field calculator. And in this case, we're going to call these the ones. So I just say RR equals 1. Okay, and it applies it. And I'm just going to go back now to selection and say clear selected features. And we're going to do this 3 times over now. So if you want to speed up the video, this is a good time to do that. If you know how to do this process, or you can just stay with me. I'm just going to walk through each one of these. So the first one is going to be select by attributes. And I need to make sure that I select everything correctly. And I need to make sure that I'm not selecting on top of other selections. So I have currently 0, which is exactly right. I'm going to say create a new selection. And we're going to do the incidence first. So it's going to be norm tornado is going to, in this case, be less than 3.22. Say apply. And select from the current selection. We're going to go and do mobile home. So in this case, it's going to be greater than or equal to 11.22. Say apply. Okay. And these are going to get 2s. I'm going to say don't do that again. So now it's 2s. I can see it taking effect in the attribute table. Selection, clear the selected features. Select by attribute. Now I'm on to number 3. Create a new selection. We're going to go to the incidence first, which is going to be norm torn is going to now be greater than or equal to 3.22. 3.22. So apply. And then I'm going to go to select from current selection, mobile home. Mobile home in this case is going to be less than 11.22. Apply it and say OK. And I'm just going to make sure that I got it right. So I'm going to look through. It looks like I did get it right. It's not selecting on top of 1s and 2s. So under my field calculator, I'm going to give this a 3 and say OK. And then we're going to clear selected features and do our 4th. So select by attributes. In this case, I'm going to be creating a new selection. And I'm going to do my incidence first, which is tornadoes. And these guys are going to be greater than or equal to 3.22. All right. And then I'm going to go back and select from the current where the mobile home is very high. So mobile homes in this case are going to be greater than or equal to 11.22. Greater than or equal to 11.22. And apply that. And then I get 651. And that looks like the correct pattern because we know that the tornadoes really happen in the south, a lot in Florida. And then we also have some counties up here in the north too. And I'm not selecting on top of other selections, which is exactly what I want. It's just getting a lot of nulls there. Okay, we're going to call that a 4 and say OK. All right. So let's clear these out. And we know that we still have nulls. And let's just kind of take a look at those nulls real fast. So I'm just going to do this interactively in the table. So these nulls are locations where there wasn't a hurricane strike. So if we go into our original strike data. And let's just zoom in to some of these. All right, so we can see that there wasn't any, we're just visually looking here. We can't see any strikes that have taken place. In counties close, that is indeed the case. We can make this a little bit bigger. Okay, so these little ones that we didn't see before, they're showing up adjacent, but not in the ones that are currently selected. Okay. All right. So now what we're going to do is we're going to thematically map this. So let's go to our county, and we need to zoom to layer. Okay, so we're going to be mapping at this scale right here under properties, and we want to go to symbology. In this case, it's going to be quantities, and we want to do our risk rank, and we could do a color ramp if we want to. That's fine. Yeah, let's just do that and say apply. Okay. Okay, there it is. And we can see that we're missing values here, which doesn't really look that great. Let's go back in under properties and see if we could do this as categories. Yeah, it'll let us do that. Okay, so instead of doing it under quantities, I'm going to go to properties, and I think we could do this a little bit more effectively here. So I'm going to add all values for risk rank, and we can see that we don't have any other values beyond null 1, 2, 3, and 4, which is exactly right. So let's click off that. Now our nulls, those are the ones that don't have a tornado strike. Let's just make this kind of a neutral gray. So I'm just going to make it a gray. And for my ones, that's going to be where there's low incidence and low exposure. That's LI, LE. Those can be just kind of a beigey color, because that's not really a risk. Now my twos are low incidence and high exposure. So although you're really exposed, there's lots of tornadoes, there's not really anything at risk, at least in the physical environment. So we can make that a little bit more urgent, maybe a solar yellow, or actually just a little bit brighter yellow. Threes are a situation where we do have lots of tornadoes, or I should say, no, this is where we have, yeah, we have lots of tornadoes, and we have a low count of mobile homes, which is different than the number two. Number two is where we have low hurricanes, but a lot of mobile homes. Sorry, I think I might have got that confused. So we'll make this a little bit more urgent, slightly more urgent. But the one that we're really interested here is number 4, which is where we have really high levels of tornadoes, and we have really high levels of mobile homes. So in this case, we're going to make that a kind of a dark red and say OK. And we can see this makes sense in terms of our count number. So of all our counties, most of them are falling in the 2s and the 3s, and then on the ends, on the 1s and the 4s, we can see that our count is sort of dropping as we would expect. It's sort of a typical curve, typical histogram here in terms of just the count alone. So we can say apply, OK. And this works out pretty well. So we can see a really nice pattern of these counties that definitely have a lot of risk in them in the built environment, but they also have a really high prevalence of hurricanes. So these are the ones that we would need to worry about. And we can see, interestingly, there are patterns here. There really are hotspots. We could run a hotspot analysis on this. We could do a few other statistical tests, But as a first pass, this kind of gives us a pretty good idea of where the major risk is in terms of the built environment and tornado occurrences. One issue that probably needs to be visited and solved is if we zoom in here, we're going to see there are some incorporated cities that take on the larger county name, and that's an issue. So we can see here, this is in California in Sonoma County. What I'm going to do is I'm going to just put the hurricane count on top here, and let's look at what's happening here. So here there's actually no hurricanes, or excuse me, tornadoes that are taking place within this polygon, but this polygon shares the attribute of Sonoma. So we can see that we have normalized tornadoes of 0.73 here, and we actually had our original count of 11. And if we come over here, we can see that we have a really high count based on the square area that's been normalized, but the original was the 11, and it's because this thing is within this larger county where the tornadoes are actually taking place. So just be aware where you have these smaller polygons within larger polygons that share the same county. This is what's going to happen, is you're going to get this kind of over counting taking place. And it also happens on the East Coast too, in a few instances. So let's zoom back out here. And let's take a look at a couple other instances too. If we look down here in the Florida Keys, we can see that these keys, they take on a really high risk. But if we look at the actual tornadoes themselves, we can, let me make this a different color. There is a fair amount of activity that's happening here, but it's such a small square area that's the reason why it's really pushing it up quite far. Is because of this small area. So if let's just do this. Let's click on this real quickly. So here, this is the lower Keys in Monroe, and the normalized tornadoes are 41, and the original count was 34. So it's actually increasing the number because the area is so small. So as we normalize to 100 square miles, it actually increased the normalized tornado count. So for these smaller areas, they kind of experience a little bit of exaggeration. And then also one other issue that's taking place that's worth noting. Let me get into my table of contents here. If we take a look at this county, Pinellas County, this county right here, this is right along the coast. It has a really high count. So its original count was 109 strikes, and it was normalized down to 35. And the reason that it didn't get a 4 is because its actual mobile home count was pretty close to the median, but it was under. So a more probably appropriate ranking for this particular county would be maybe a 4, because if we actually look at the amount of tornadoes that come across this county, it's really quite extreme. So these are kind of the limit. We can see just how many have come across this area. So just the fact that there's so many tornadoes happening, but it's in a relatively small area, we might want to, on the second pass of vulnerability ranking, if we were doing, say, Florida, we will want to take into consideration where our breaks are falling for the ranking that would probably put this into a higher category. But this suffices, I think, for having these 4 classes at a scale of the United States itself. So if I go to zoom to layer here and zoom out, this is a pretty telling map. And then what I would want to do here to produce this map is make sure that 1, 2, 3, 4 are being described in terms of what they actually are ranking. So we would want to, in text, under the legend, explain that it's the first class is low incidence, low exposure. Second class is low incidence, high exposure. Third class is high incidence, low exposure. And then the fourth class is high incidence, high exposure. We would want to put that into text as opposed to just 1, 2, 3, 4, or somehow, notate it in a subtitle in some way to explain exactly what it is that we're mapping here. So hopefully this this extra credit is helpful to understand how to take a actual incident count of something that's happening. It could be an environmental factor. It could be a natural hazard that's taking place across a continuous surface, but we want to then collect that into specific polygons where we're going to have some socioeconomic data. The identification process works pretty good to do that, and then summarizing the table, and then finally we did the risk ranking on top of that to produce the final map. So, and again, for this extra credit assignment, if you want to focus in on one state, or if you want to actually use different variables beyond the mobile home percentage per county, that could be really interesting too. Maybe using the SVI, social vulnerability themes that are in that particular data could be an interesting approach also.